Okay, so in this example, it says change the function, and they give us a function so that this same function is written in the form y equals a naught e to the kt. So that's our, growth decay model that we've been using. And they're saying, we have this function, but it's not quite in that form, and we'd like it to be. So to do that, we're going to have to use one of our properties. And the property we're going to use is one of the inverse properties. So you might remember when you had b to the power of log base b of x, that just equaled x. I don't know if you remember that one, but that was one of our basic properties. Well, what we're going to do is we're going to go the other way. We want e to be the base, right? Because that's what we have here. But right now, the base that we have is that 3.1. So if x is 3.1 on the right, and I want a base of e on the left, then I need a natural log of 3.1. That if I had this, e to the power of natural log 3.1, that would just equal the 3.1. So you can think about that for a minute. Might have to rewind and watch that part again because it's a little odd. We're going from something simple like 3.1 to something more complex. And usually in math we don't like to do that. We like to simplify things, right? Okay, so we're saying we can replace 3.1 with e to the power of natural log of 3.1. Okay, so that's what we're going to do. We're going to take this right here, and we're going to plug it in for 3.1. So now I'm going to have y equals 2.5 times, and it's going to be that e to the natural log of 3.1 to the x. Okay? Now, how do we work with powers? If we have an exponent in the parentheses and an exponent outside, we're going to multiply those. So we get 2.5 e to the x natural log of 3.1. Okay, we can also write that as 2.5 e to the natural log of 3.1 times x. And that's fine. That's the model. That's what we were looking for. You'll notice over here then, we know what a naught is. That was the 2.5. And the constant is that natural log of 3.1. Now, a lot of times they'll get a decimal approximation and use that for there. But this time they just leave it natural log of 3.1. But it's a number. We can get a decimal approximation. Let's see what it is. It's natural log 3.1. Yeah, it looks like it's about 1.1314. That would be an approximation that you could put in, and then you'd have a formula that you could use, a model that would be a little bit easier to use and recognize as, well, it'd be a growth model because k is positive. Okay, so that's what we're doing.